Well, hi again, this is Bob, and we're over on page 453, and we're getting ready to introduce something that we've worked over once before in Chapter 7, and this is the z-test for a proportion. And I thought I'd just start off by writing our old value for a z-test. When I say old value, I mean at the beginning of the chapter. And what we're dealing with now, and this is what they use to derive the formula, but here's our new formula when we're dealing with the population proportion. You may recall, and as I said, we went through 7.3 for confidence intervals for population proportions, and if you want to, or if you need to review a little bit, that was back on page 390 and page 391. But we covered this pretty good with introduction and lots of problems worked. So hopefully that'll come back to you. And underneath, or in our denominator, we have P times Q all divided by N. And please make sure you can see that everything is under the radical in the denominator there. And another thing to mention when we're going to use our new formula is notice that Q hat does not appear in our formula, so we don't have to find that. Now, they tell us in the middle of the page, actually there was one more thing that they told us, although normally we can do it in our head. They told us that P hat equals X over N, where X is the number of the best way to phrase that would be X would be the number of individuals or data entries that have the particular trait over the sample size. Okay, anyway, what they tell us is that this new formula that I've just written is derived from our previous formula for the z-values, and then they do some fancy algebraic derivation. And I think somewhere in the back of the book they may actually show the derivation, but what we're really interested in is using the formula. Okay, and as I work through a couple of examples in this section, I'll come back and remind us some of the important points of the population proportion that we saw in section 7.3. They also tell us at the bottom of page 453 that there are two assumptions, and we've seen these before also for testing a proportion. And of course, when they say proportion, they mean population proportion. It's like the true mean. This is a true population proportion. And they tell us that the sample is a random sample, which we've seen all along. And you may recall that NP, when multiplied together, must be greater than 5, as well as NQ, when multiplied together, must be greater than 5. That's the assumptions we need to use the formula. Oops, greater than or equal to 5. So let's go see what's happening. I'm only going to work a couple of examples here because this we've pretty much done everything in terms of using these new formulas and coming up with the ideas of hypotheses testing. And so I thought I'd do example 817, which deals with the formula itself. It just happens to deal with a two-tailed test. And then I'm going to do 820, which deals with converting a z-value into a p-value. And both of these skills we really have worked over pretty well. Anyway, in 817, it talks about the obesity in young people. And we have a researcher that claims that based on information from the Centers for Disease Control and Prevention, 17% of young people ages 2 to 19 are obese. And then we're going to test this claim. To test the claim, the researcher randomly selected 200 people ages 2 to 19 and found that 42 were obese. And then at alpha 0.05, is there enough evidence to reject the claim? Well, here's some things that we should know. We're dealing with alpha 0.05. The claim says, and this goes with our null hypotheses, note this will be a two-tailed test because we don't know, the researcher's not claiming that the true population proportion is bigger than, where's that percentage at, 17% or less than 17%. They're just checking or verifying or testing the figure that's already been established or accepted. So it just so happens that in this case, the researcher is claiming that the, I'm just double checking my reading here. Yes, the claim, this is another reason why I personally don't like the term claim as much, because sometimes it's hard to figure it out, but it says the researcher claims based on this information from the report, and then we've already seen that information. Okay, so the claim will go with the null hypotheses, and since we don't know in which direction the answer will lie, in other words, the researcher really doesn't know whether the true population proportion will be on the right side of the graph, or standard normal distribution, or on the left side, and that's what makes this a two-tailed test. And of course, the alternative hypotheses would be that it's not equal to 0.17, but we don't know on which side it will lie. Or we may get a larger or smaller sample proportion, if you will, but we still don't know whether it will be statistically significant. All right, well, the other information that we know here was that 42, if we want to find our p hat, recall that that's x over n, and that would be the 42 test members that were overweight or obese divided by 200, and that gives us a p hat of 0.21. Recall, we do not need q hat. Now, normally I would have written this first, but if our true population proportion is equal to 0.17, recall from section 7.3 that Q would be equal to the complement, or 0.83 in this case. Okay, so and then of course the other piece of information we have is that n equals 200. Now, every individual will sort of set up these questions differently, but as I've mentioned before, I personally like to get as much information written down as I can, and then normally I would go to the null hypotheses and the alternative hypotheses. Anyway, I think we've, I'll just remind us that we need alpha 0.05, and also before I would go to work on this question, I would do my sketch. And at alpha 0.05, remember we need to, this is a two-tailed test, so we need to find alpha over 2 so we can find our critical values. Although you could have just gone and looked them up in section 8.1 already, but this will give us a little practice also, or reminder. So what we're going to have at alpha 0.05 is 95% of the graph in the non-critical region, and then 2.5% in each critical region. And of course, the z-values that go along with a two-tailed test at alpha 0.05 are 1.96 and minus 1.96. Now, again, this, we don't have to go to the z-tables. This is summarized in 8.1. Now what we're going to do is figure out our z-value. our p hat was equal to 0.21. Our established population proportion, we're testing the claim here, was 0.17. I'll draw a nice big square root there. So P was 0.17. Q, of course, its complement is 0.83. And our sample size was 200. Now, I'm not going through the, I've checked, of course, the calculation ahead of time, but please make sure that you're doing these on your calculator and you're coming up with the same answer that the book is. It's so easy to make a order of operations error or just a simple calculator input error, and there's a lot going on in that formula. Normally, the way I would approach this would be I'd find the numerator, and then I'd find the denominator, and then I would do a separate step, my last step, of dividing the numerator by the denominator. Anyway, the z they got is 1.51, and of course, going to what we just showed a second ago, just take me a second to write this up there. Let's say 151 would be about right there. 151 is not in the critical region. Or said differently, 1.51 is not bigger than 1.96, so we will not reject the null hypotheses. Now, the way the book worded it was the not enough evidence to reject the claim that 17% of young people ages 2 to 19 are obese. Okay, in this particular case, the claim went with the null hypotheses. All right, well, since we've done lots of these already, I'm going to leave 8.18, example 8.18 and 8.19 for you to look over. And I wanted to do an example that had us work the problem and then convert our z value to a p-value. And that there's a good question like that over on example 8.20. This will be a little shorter lesson. And this talks about attorney advertising, and we have an attorney that claims that greater than 25% of all lawyers advertise. Well, the moment I hear greater than 25%, this immediately tells me this is a right tail question. And hopefully by doing these homework questions and example questions, it clicks to you that whenever you hear words like more than or greater than or exceeds, that we immediately think of right tail. Anyway, and that's the claim, by the way, that more than 25% of the lawyers advertise. And then to get our p hat, it says a random sample of 200 lawyers in a certain city showed that 63 had used some form of advertising. Well, why don't we take care of that right now? And of course, that would be like 31.5 over 100 or 0.315. Okay, and as long as we're at it, since we know that P was 0.25, we can find out Q by going 1 minus 0.25, so Q equals 0.75. Okay, now maybe the book doesn't do it exactly this way, but as I mentioned, I like to find as much information as I can, or at least before I start setting up the problem. And we also knew that N was 200. Okay, so we know it's a right tail test. We haven't written the hypotheses yet, but I'll do that now. And we'll also go ahead and use, normally we don't need to draw the bell curve and label it, but we'll do it for this question since this sort of reinforces the idea of our p-value when we change. The last thing I needed to write here was that it's alpha equals 0.05, And recall, this is a right-tailed test. Okay, so our null hypotheses would be that the population proportion, in this case, the number of the percentage of lawyers that advertise. And remember, the question started off with a lawyer claiming that the true population proportion is greater than 0.25. Okay, so anyway, we've already identified those other elements. Let's just go to our z-test, which would be p hat, which was 0.315, subtract p, which is 0.25, divided by p, I like to use parentheses, it's actually 0.25. Times 0.75, its complement, that's Q, don't forget, and then the whole thing is divided by 200. So again, as a reminder, I would find the difference on top, then I would find the, in one or two steps, I'd find out what the denominator was, then I would divide what I got on in the numerator by the denominator. I would not recommend, unless you are extremely confident, trying to do this entire question in one step on a calculator. Anyway, when they do this, they end up with a z-value of 2.12. Now, this time we're not going to compare that 2.12 with a critical value. What we're going to do, I'll just sketch their situation down below there. Here we have the population proportion at 0.25, and then we're going to set off a certain area. Normally we would have a critical value here, and we would compare that critical value with a z of 2.12. Okay, this time what we're going to do is we're going to change 2.12 to a p-value. And you may recall, in order for us to do that, we would go to the back of the book and we would go to the z-values and we would find the area to the left of 2.12 and we would subtract it from 1. Okay, and that's exactly what they've done in step 3. They tell us that the area to the left of 2.12 is 0.9830. And then when they subtract that from 1 minus 0.9830, here is our p-value, it's 0.0170. Okay, well, we were going to reject at alpha, or anything further into the tail than alpha equals 0.05. Remember, that's our critical area there. And we have come up with an area inside, further into the curve, of 0.0170. Clearly, our area is less than 0.05. Maybe a better way to compare these, our original alpha for our right-tailed test was 0.05. The alpha that we came up with is 0.0170. And clearly 0.0170 is less than 0.05, so that tells us that there is enough evidence based on the areas in the tail to reject the null hypotheses. Now, the way the book phrases it in step 5 is there's enough evidence to support the attorney's claim that more than 25% of the lawyers use some form of advertising. Okay, well, I prefer to just say reject the null hypotheses, but they're saying that the evidence shows we can support the claim. Anyway, I've given you enough questions, I believe, in the homework that'll make you comfortable with this particular procedure. And when we get around to the quiz and the test, there'll be a question like this also. Recall, before all tests, I give a very thorough practice test in key, and there will be a question like this on our last test. Okay, well, we're one lesson away from finishing off Chapter 8, and I'll be back with that shortly. Thank you.